Okay, here we go. So we're going to do prime factorization and GCF. The first thing we need to do is we need to look at what is a prime factorization. Prime factorization is when I take a number. So in this case, I'm going to take 24. And I'm going to break 24 down into becoming a product of prime numbers only. So my goal is to eventually get only prime numbers, but when I multiply those prime numbers together, I'll end up getting 24. Okay, so how do we do that? Okay, I'll get to that in a second. First, I want to review prime. Okay, prime. Okay, we know factors are numbers that multiply to get me a number. Okay, so like 3 and 6 are factors of 18. Okay, because 3 times 6 is 18. All right, so we know those are factors, but prime numbers are numbers that only have a factor of 1 in itself. Okay, so make that note. Factors of 1 in itself. For example, 2 is a prime number. I can only get 2 by multiplying 1 times 2. Okay? 3 is also a prime number. Okay? 3 is also a prime number. 4 would not be a prime number because 4 has a factor of 2. Okay? Because 2 times 2 is 4. So 4 is not, but 5 is. I can only get 5 by doing 1 times 5. Okay? 6 is not because 3 times 2 is 6, but 7 is. Okay? 7 is prime. 8 is not because 2 times 4 would give me 8, so that has something else. 9 is not prime, and I think this is one of the biggest mistakes that I see people make is they think that 9 is prime. I think it's because it's odd, and its only other factor is 3, which is also an odd number. So I think people get that confused that it's odd and it has a prime number as odd. So I think that that's where they get that confused too. But 9 is not. The next one is 11. Okay, 11 and then 13. Now, of course, this goes on forever. We can list prime numbers to the end of time. However, when it comes to prime factorization, you're probably not going to have to deal with anything over 13. Probably won't have to deal with anything really over 11. I just take it one more spot just in case. Okay. All right. So 24. So I'm going to break it into 2 factors that it has. Okay, and I know that 24 has a factor of 3 times 8. Okay, now, could I have used any other one? Of course you could have. I could have used 2 times 12. That would have been fine. The only one I would not have used, obviously, was 24 times 1, because that just leaves me with 24 again. Okay, so I don't want to do that. So we don't want to do anything times 1 while we're doing prime factorizations. Okay. Now, 3 is a prime number. See, it's in my list of prime numbers. So 3 is, I'm going to stop breaking down 3 because I can't break it down into anything else other than 1 times 3. And I don't want to use 1 times anything in my prime factorization. So another thing when I do prime factorization, I call my prime numbers the stopping numbers. Okay, so those are my stopping numbers. Those are the numbers that I stop at. Okay, so I'm stopping here, but 8 is not a stopping number for me, right? It's not prime, so I still have to break down 8. Okay, so I go ahead and I take 8. I'm going to break that down into really the only 2 factors I know, the only 2 factors there are, into 2 times 4. Okay, Now, stopping numbers. 2 is a prime number, so that's a stopping number. So I'm going to stop with 2. But I look at my list. Oh, 4 is not a stopping number, so I have to break down 4 still. Okay, so here I go. I'm going to break down 4. And I think that really only has 1 also, and that's 2 times 2. Okay, so that's 2 times 2. Both of these are stopping numbers. Both of these are prime. So I stop with them. Now I have nothing else to break down because I've stopped at everything else. So now I have 3, 2, 2, and 2. Okay, so my prime factorization of 24 is 3 times 2 times 2 times 2. Okay, so there's prime factorization. All right, so now we're going to go on to the next line of business is prime factorization and greatest common factor. Yes, we can use prime factorization in order to help us find the greatest common factor of 2 numbers. Okay, quickly, I'm going to review greatest common factor. Okay, greatest common factor, trying to find greatest common factor of 12 and I'm going to do 12 and what should I do? 12 and 21. Okay, we're going to do greatest common factor of 12 and 21. Some of you probably know it right off the top of your head if you're familiar with it. Okay, so I find what are the factors of 12. I always like to list them out like this. I always like to list them out in their factor pair. Okay, so that's what we've done before. List them out in their factor pair. So 1 times 12, and I also know I can do 2 times 6. I also know I can do 3 times 4. And then I say, okay, so I can do 1, I can do 2, I can do 3. Can I do 4? Oh, well, I've already used 4. So now that I've already used 4, I know I'm done. 1, 2, 3, 4, 6, and 12 are the factors of 12. So I go to 21, and I know, okay, 1 times 21. 2, well, it doesn't end in an even number, so I know 2 can't be a factor. So I'm not going to use 2. 3, well, you know what? I don't know if 3 is a factor. Maybe I don't know that if 3 is a factor, or I'm not sure. Okay, we can first check our rules. Okay, so 21. Okay, so we add 2 and 1. 2 plus 1 is 3. Well, 3 is a factor of 3. So 3 is a factor. So I know based on my divisibility rule that 2 plus 1 is 3. I know that 3 is a factor. But I still am having a hard time knowing what is it a factor? 3 times what? Well, I can go ahead and divide that out. 21 divided by 3. 3 goes into 21. Let me see. 3, 6, 9, 12, 15, 18, 21. Oh, 21. I stopped at 21 and then I got to 7. So 7. So 3 times 7 is 21. Okay, and I know that's true. 3 times 7, 21. I get a factor or remainder of 0. Okay, now I say, okay, what about 4? I'm not sure about 4. So you know what? Well, if I'm not sure about 4, I'm going to go ahead and I'm going to multiply it and divide it out. 21 divided by 4. Well, 4 doesn't go into 2. Does 4 go into 21? Let's see. I have 4, 8, 12, 16, 20, 24. Oh, 2, it's not even. So 4 is not going to be a factor. 5 doesn't end in 0 or 5, so I know 5 is not a factor. 6, okay, maybe the same thing. Let me try 6. Divide by 6. 6 goes into 21. Let's see. 6, 12, and then 18, and then 24. So, too high, so it doesn't work. Then I hit me at 7. Well, I've already used 7, so here are my factors. 1, 3, 7, 21. Okay, greatest common factor is the largest number that they both have in common in their factors. In this case, it's 3. So GCF. equals 3, okay? There's a review of greatest common factor. But we can also use find the greatest common factor if we go ahead and break down two numbers into their prime factorization. Okay. For this one, I'm going to do 24. Since we broke that down, maybe I'll break it down a little differently and show you that it doesn't matter which ones you start with. So 24 and 42. Okay. All right. Now, if you were in my Google Meet, you know that we already found the greatest common factor of 24 and 42. But I like to use them just because it's easy for me to remember 24, 42, the reverse, and they have quite a few numbers in common also. Okay, so 24 and 42. So I'm going to break down my 24. Okay. Last time we started with 3 times 8. But this time I'm just going to start with 2 times 12. Let's say I didn't know about 3. So I'm like, oh, okay, it ends in a 4. I know 2 is a factor. So 2 times 12. Okay, 2, that's a stopping number for me, right? So here I go. I'm going to box in my stopping number. 12 is not. I know I'm going to go 2 times 6. Okay, so 2 times 6. 2 is a stopping number. 6 is not. I break down 6. 3 times 2. Okay, 3 and 2 are both stop numbers. Okay, last time when we did the prime factorization, remember we ended up with 3 times 2 times 2 times 2. Okay, well, you might be like, well, that's not the same because here I get 2 times 2 times 3 times 2. Well, it is the same. Remember, commutative property of multiplication says no matter what order I multiply in, I'm going to get the same number. So even though I end up with 2 times 2 times 3 times 2, I'm still going to get the same thing. Okay? And I actually like it better when we go from largest prime number through lowest prime number. Okay, so I actually like it in this case. Even if I get this, I would end up writing it 3 times 2 times 2 times 2. Okay, all right, and that's just to help with organization, OCD issues, whatever. Okay, so now 42. I'm going to break down 42. Okay, 42. I don't know. I know that 2 is a factor, so I'm going to go with 2. Okay, 2 times, oh, and I'm not sure what 2 times what. Okay, so I'm going to do 42. 2 goes into 4, 2 times 2 is 4. 0, bring down the 2. 2 goes into 2, 1 time, 2. Okay, good. So 21, 2 times 21. Okay, 2 is a stopping number. Okay, 21. I can break down 21 into 3 times 7. Right, 3 times 7, both of those are stopping numbers. Okay, so now I have 7 times 3 times 2. See how I went from largest to smallest? It doesn't, again, order's not going to matter. Okay, all right, so I go from largest to smallest. And now, to find out the greatest common factor, I look at my 2 prime factorizations. Okay, I have a 3 here, and I have a 3 here. I have a 2 here, and I have a 2 here. Right? Now, do I have another 2? No, I don't. I'm done. So now if I just do 3 times 2, I will get 6, which is the greatest common factor of 24 and 42. Okay? If you don't believe that, factors of 24. 1 times 24. 2 times 12. 3 times 8. 4 times 6. Okay, factors of 42. 1 times 42. 2 times 21. 3 times 14. Not 4, not 5. 6. 6 times 7. I have 7. There we go. There's my greatest common factor of 6. Okay, so either way, I 100% prefer this way because this way I don't have to know or memorize all the factors. If I just know a few of them, if I just know one pair of factors, then I can kind of break this down and figure it out. Okay. All right, so I hope that's pretty cut and dry. The last one I'm going to have you guys do. Right, remember, I want you guys to go ahead and do this on your own. One. Okay. And when you do this, you can take a picture of your work and email it to me, or you can do it on a Google Doc. I think doing a picture and then emailing me the picture is a lot easier. You guys know how to screenshot on your phone. You guys should know how to screenshot on your Chromebook. You guys should also know how to just take a picture using your Chromebook. I know you guys do that. I've seen you do it before in class. So here we go. What I want you to do is I want you to use the prime factorization. Use prime factorization to find the GCF of 32 and 32 and sorry, hold on. 32 and 36. All right, so I'm going to do that. I'm going to use that for you guys. Okay, find greatest common factor of 32 and 36. Go ahead and use prime factorization. So I'm going to want to see a factor tree for 32, a factor tree for 36. I'm going to want to see what the prime factorization of each of those are, and then that you're combining the prime factors and you're multiplying them out to figure out what the greatest common factor is. Okay. Okay, go ahead and do that, and good luck, and make sure to go ahead and submit those to me.